Hi everyone. Thank you, Strangely, for having me. My name is Amy Wibowo, and on the internet I am Sailor HG. I recently left my job as a web developer at Airbnb to write zines about computer science because I don't feel like we currently emphasize enough the creative aspects of computer science and also how much computer science can tie into other subjects in computer science education. And with that as a segue, today I'm going to talk to you about knitting. Now, before you get up to leave because you think you might be at the wrong conference, I want to assure you that this talk is about problem solving, hardware hacking, and even has some programming and some code in it. You're just going to have to wait to see how. So all stories start with an inspiration, and here is a somewhat unexpected start of this story. A few years ago, a video game website called Kotaku published an article about Super Nintendo peripherals that never quite made the cut. You've probably heard of some of the outlandish add-ons that did get produced. There was a baseball bat for playing baseball video games, a golf club for playing golf video games, a Super Scope wireless gun for shooting games, but you might not have known that Nintendo was seriously contemplating making a knitting peripheral for the SNES. And this is the proposed advertisement for this peripheral, complete with horrible puns. I'm not sure if you can read it, but in the bottom right corner, it literally says, "Why needle the competition?" So the interface would be like Mariopaint, but instead of just pictures as outputs, you could get your design on a scarf or mittens or socks. So most of the comments left on the Kotaku article were along the lines of, "Lol, we see why this one never made it to production," or "What were they even thinking?" But I had a really different reaction to reading this article, and it was that I was so heartbroken because I had never wanted so badly for something to exist. I felt like if I had one, I would just use it all the time and make myself all kinds of socks and sweaters and mittens. And so then it was time for me to do research. Did Nintendo have any prototypes that I could get my hands on? Was there any other company that made knitting machines for home use? After a lot of research, it turned out that a bunch of companies made knitting machines in the 1980s, but they never really took off, so they were discontinued. And that's when my dream was born, to get my hands on one of these old machines and to make the Super Nintendo add-on that never was. And as fate would have it, I found one of these super old knitting machines on Craigslist at an address about an hour and a half away, and it was old and parts were missing, but it was a start. It was a start to my dream. And to summarize this dream again in cartoon form, it was to have a knitting machine that could take images from my computer and turn them into sweaters, basically to create a networked yarn printer. So now that I had gotten hold of one of these things, the first thing I needed to do was learn how to use the damn thing, because just figuring out how to use the built-in basic functionality of the knitting machine, let alone hacking it, was daunting because this is what a knitting machine looks like. It has 200 knitting needles that move in and out. You can thread up to 2 different colors of yarn to produce patterns. And it came with a manual that was like this thick, that was full of knitting terms that I had never heard of. And if this is what using a knitting machine looks like, this is what using a knitting machine feels like. There are so many buttons and moving parts. It totally felt like operating the control station of a starship. Like my teammates and I would later joke about how we felt like we were basically playing Space Team. And I was worried that if I pressed the wrong thing, this would happen. Or at least that I would break some of the needles and have no idea how to fix them. Luckily, I had a team of people to help me face the knitting machine that was both fearless and inventive. This is the team of Airbnb engineers that helped me hack a knitting machine for one of Airbnb's internal hackathons. Airbnb hosts internal hackathons twice a year for the entire product team, both designers and engineers. And a lot of people now ask me, how did you ever convince anyone to work on this with you? And believe me, I'm surprised too. I had no idea if anyone else would be interested in working on this project with me, so I was really surprised that there was so much interest. When I pitched that idea So many people came up to me saying that they wanted to work on it with me that were as excited as I was or even more excited. And there were so many different kinds of engineers that signed up to help me. An iOS engineer, an SRE, a performance engineer, a data infrastructure engineer, a front-end engineer. And that's all to say that we were a bunch of engineers who knew nothing about knitting or knitting machines. So this was just kind of a crazy adventure that we were all in on together. And I think that that made it one of the best teams that I've ever worked with. We had zero ego attached to machine knitting, and so this was just an adventure that we were all in together. Going back to Jabba the Hutt, the reason we had to be fearless was that the knitting machine was really daunting, and this was a problem we had no idea how to solve. And inventive because this was technology from the 80s, and the machine was missing some of its parts, and we had to MacGyver some replacement parts. But the good thing about being an engineer is that you can apply your problem-solving skills to anything, even knitting. So this is an example of a problem that we needed to be resourceful and inventive to solve. It felt like we were encountering problems at every step of the way, even before turning the machine on. Just preparing the yarn for the machine was difficult. When you buy yarn from a store, you'll usually find that it's in a ball or in a little twist, and that's because it's optimized for hand knitters. But in order to feed yarn into a machine, it has to be wound into a spool, kind of like for a sewing machine. And if it's in a spool, then it can be fed into the machine at an even rate. So our machine came with a contraption to turn balls of yarn into spools, but it had a bunch of parts missing. So we had to MacGyver a solution from paper cups. And this is one of my teammates, Dave, using our MacGyvered coffee cup spooler. So after we set up the machine and successfully learned to knit solid rows of a single color, the next step was to use the machine to knit some of its built-in patterns. It comes with a book listing samples of all the patterns and the numbers that you could input to use them. And it forms the patterns by alternating two different colors of yarn. And even though this was something that was built into the machine already, it still felt like we were leveling up in machine knitting because it required reading like an extra 20 pages in the manual, and there was like twice as much yarn that could get tangled. And just to show you how non-trivial this step was, on the left is our first attempt to knit a built-in pattern, which was supposed to look like polka dots. And after a couple hours, you can see the polka dots we finally knit on the right. Another example of using engineering problem solving for knitting was that the machine, we noticed that it would tend to get stuck more often with two different colors of yarn, which makes sense, there's like more to get tangled. So we experimented with like different thicknesses of yarn and different materials of yarn and wrote down which ones tended to work best and like adjusted our hypotheses from our observations. So we ended up finding out that using animal-based yarns were less likely to get stuck, and we think that it was because of the natural oils that were already in the fibers. So after we figured out how to knit the machine's built-in patterns, we still hadn't achieved our dream yet. As far as we could tell, the intended user of a knitting machine from the 1980s was a grandma, because the built-in patterns were all things like bows and teddy bears, and I don't know about you, but I would rather have a sweater with a grumpy cat on it than a sweater with a teddy bear. So we still wanted to figure out how to send the machine our own images, which was step 3 of our goal. And this goal we would split into several parts. So because it's from the 1980s, the knitting machine takes additional patterns via floppy drive. Back then you could buy additional pattern packs on floppy disks. So we could send our own images to the knitting machine by emulating a floppy drive on our computer. And then we needed to build a custom cable because the knitting machine had a serial input and output, but it had a really strange pinout. So we had to research what the pinout for the machine was and build our own custom cable that was USB to serial port. The next step was to convert our input images to low-res 1-bit bitmaps, which was the file format for the knitting machine. There were a couple different ways to do this, but we wanted to use the conversion algorithm that supported dithering, and luckily we also found a library for this piece. So with all these pieces together, we can have our knitting machine read from our computer as if it were a floppy drive. So here's one of our first custom patterns. Note the dithering on the Shiba Inu. If it's hard to read, it says, wow, oh my God, such fair isle. And here's Grumpy Cat. So we were having entirely too much fun with this, but we kind of felt like we were hogging all of the fun. We didn't want sending pictures to the knitting machine to be limited to just us who had been learning how to use the machine for a couple days. We wanted anyone in our office to be able to print memes from yarn. We wanted to share the fun. So the next step was to make machine knitting available on the web. It would be a super simple interface. You would choose a photo to upload. You would send the image to the machine, and then the web browser would give you instructions for the buttons to press on the machine to start knitting your pattern. And here's a video of the whole thing in action. And I have a bunch of knitting samples with me here if you want to come look at them later. And here's a close-up of the input image and the knitted output in case it was too small in the video. And now we can look at the code that made this possible. It's in Ruby and Sinatra, and it's super simple. So we load in some libraries, including a wrapper library for a wrapper for a library that converts the images to 1-bit bitmaps that we call knitting patterns, and then a wrapper for the floppy disk drive library that we call pattern disk drive. And then when the user presses the upload button, we save the user's photo to a file, use the image processing library to convert the image to a 1-bit bitmap, and then start emulating the floppy disk drive. And then meanwhile, in the web browser, we display instructions for the user for which buttons they should be pressing on the knitting machine. And this is the view for the upload form. So the things that we learned on this little adventure. First of all, we gained mad respect for grandmothers and anyone who knits because that shit is hard. I recall so many times that my teammates said things like, I thought that my job was hard, but optimizing database queries has nothing on this. Another learning was that teams work really well when everyone operates with zero ego at stake. Also, it's really enjoyable to apply programming to any of your hobbies, no matter how unrelated they might seem. especially hobbies related to creating. And also, when you start exploring the union of technology and other hobbies, you discover how similar they are. I would have never guessed that I would be making off-by-one errors in knitting too. Then the last learning is that it feels really great to take up something that you know nothing about. So many of my teammates said it was the most fun and challenging thing they had done all year. Learning something brand new and very different from what you do day to day is really humbling, challenging, and refreshing. And it reminds you what it's like to be a beginner, which is really important to gain empathy with any new programmers that you might work with or mentor. And there's a lot left to do and explore in this whole space. And the amazing thing about giving this talk at conferences is that at every conference, people have talked to me about interesting ideas for how to take the knitting machine further. On the web interface axis, it would be great to make an interface where you can draw an image and send that to the knitting machine without needing to use an already existing image. And maybe it could even preview what your design would look like with different colored yarn. And another goal I had for a while after hacking the knitting machine was to learn how to use the machine itself better, to knit whole garments like socks, sweaters, socks with toes. And then when I gave this talk at Madison Ruby, a programmer named Liz Abenante, who is also a knitter, told me about a knitting machine academy in Seattle where they teach you how to use old knitting machines to make full garments. So I signed up for a weekend intensive there, brought my computer and my cable, and learned to make all the pieces of the sweater I'm wearing right now. And the lesson there is that sharing what you've worked on with the community and audience just makes the project even better. On the hardware hacking axis, it would be amazing to figure out how to automate more of the knitting process, like a robotic arm that moves back and forth. And I've also been reading about hacks that replace the whole logic board of the knitting machine with an Arduino, and that would be fun to try too, to be able to control more of the interface of the knitting machine itself, like showing your progress and how much more you have left to knit. And lastly, I would love to talk to you about your ideas if you care about hardware hacking, knitting, combining code with art, or creative ideas for computer science education. Thank you so much for listening and so much for having me. And I think we probably have time for some questions. Yes?
Did you see your sweater yourself, or could the machine do that?
So the question was, did I seam the sweater myself, or did the machine do that? So I guess when machine knitting, there's something called a joiner. It's like an additional machine, and you like put the pieces on it, and it puts them together. So it's like a separate component.
In the video, you show one complete cycle that proves a little square foot of image. How long was that in real time?
So the question was, how long did the knitting in the video take in real time? I would say about 15 minutes, but that's still like much shorter than it would take to knit that by hand. Yes?
Is your machine able to incorporate like conductive thread or other kind of wearable technologies?
So the question was if the machine could take in conductive thread or other wearable technologies, and it should totally be able to, and I haven't tried, and that's an amazing idea. Thank you. Yes?
What kind of feedback did you get when you proposed this to the community at large? When you brought up, hey, I want to do knitting. That's kind of the hackathon idea. Did management or anybody
I guess hackathons at Airbnb were really funny. Maybe partly because of this knitting machine project, and basically every single other project idea I had was completely unrelated to web development or our day-to-day product. But they thought that it sounded like a fun project and that we should go ahead and do it.
You mentioned that you want to explore options
So the question was, I mentioned wanting to introduce more creative ideas in computer science education, and if I've incorporated this knitting project into that. And I haven't, and I definitely do. So I'm currently writing a series of zines, one a month, about different computer science topics. And so far, I've covered things like logic circuits and sorting and computer memory. And the plan for the December zine was to interview a bunch of people who have done interesting things with computer science that you don't normally think of when you think of computer science. I have friends who use computer science for social justice applications or to make like generative visual art, and I want like a chapter for each of those things so that high school students will know like, wow, these are the range of things that I can do with computer science. Mm-hmm.
Have you thought about hacking an actual Super Nintendo to realizing Nintendo's
That would be super amazing. I would love to do that. Yes? The question was, did I reach out to Nintendo at all, and did they respond? I didn't. As soon as I read that they didn't have any prototypes available, I just like went full on into like searching for machines that could do it. I do wonder if they would be willing to like revisit that though, and I would totally want to help make that happen. Uh-huh.
Are you aware of that person, I think in California, who's knitting the cellular automata scarves?
Oh yeah, we're friends. She's really awesome. Mm-hmm. So yeah, this machine only did 2 colors. You can get like an add-on to do up to 4 colors. Mm-hmm.
How expensive are these machines, and have you like posted the build steps anywhere?
So the question was, how expensive are the machines, and have I posted the build steps anywhere? So I think it varies. The one that I got on Craigslist was $500, and I expensed it. And the other question was about whether there's like a resource list. And a couple knitting clubs have asked me if like I've detailed my steps anywhere, so that they can like recreate it. And so I've definitely sent out the list of steps to some people, and I should probably make it public and send that out. Thanks so much.